Welcome back to question 2. I just wanted to make a little note that it'll be good for you to do a lot of graph questions today. By a lot, I mean 10, um, so that you could remember how to figure out gradients. Because unlike the last graph, which was the number one to this, there was no gradient. You did a lot of extrapolation. So I would like you to look for more past papers to do your gradients. I'll just look through the videos on this site on my channel and see if you find any more videos with graphs that include gradients. So this one says distinguish between inverse and longitudinal waves. A transverse between transverse and longitudinal waves. So a transverse wave is one that has vibrations perpendicular to its direction of propagation, and a longitudinal wave is one that has vibrations parallel to its direction of propagation. So remember, transverse waves are like this, and longitudinal waves, they, remember, that's the one where you have the compressions and the refractions, so this one is longitudinal, which goes back and forth, and this one goes up and down. Now, state one example each of transverse and longitudinal waves. So it's just asking for an example of a transverse wave, and we already know that light is an example of a transverse wave, and sound is our example of a longitudinal wave. In the equation, velocity, frequency, and wavelength are related. Write the equation. So this is it right here. V is equal to frequency times lambda. Lambda. Now, a wave motion has a frequency of 10 hertz and a wavelength of 250 meters. Calculate the speed of the wave. So you just say V equals to 10, which is frequency, 10 per second times 250 meters. This is the wavelength, and you get 2500 meters per second. Okay, so now we are on B2B, and it says indicate on figure 4 the amplitude of the wave. Using figure 4, determine the wave's amplitude in meters, period in seconds, and frequency in hertz. So the amplitude is always the distance between the point of equilibrium, which is this, to the top of a crest, or between the point of equilibrium and the bottom of a trough. So either one is fine. We indicated it, and we could now put an arrow and say amplitude. Okay, we could also do that, amplitude, same thing. Now it says using figure 4 determine the wave's amplitude in meters. So amplitude is from here to here, so 0.5 millimeter. Yes. All right, so the period in seconds is from here right over to here. So you have to have a crest and a trough. All right, so the first cycle takes 4 milliseconds. So it's going to be 4.0 times 10 to the negative 3 seconds. Because remember, a milli is equal to 10 to the negative 3. Now for hertz, how you calculate hertz? Our frequency is equal to period, 1 over period. With frequency now, you would divide 1 by the period, okay? Because like saying, if one cycle is produced in 4.0 times 10 to the negative 3 seconds, how many cycles will be produced in 1 second? That's what's the frequency, the amount of cycles produced in a second. And if you look at it, you'll see if you cross multiply, you have 1 divided by 4 equals x, which is basically this. So it's a 1 divided by 4. Well, 4 times 10. 1 divided by 4 times 10 to the negative 3. So that's what you have here. And you know you're going correct because you have the correct units. And that will give us, you see? That will give us, like it's 250 per second, or 250 hertz. So this would have given us 6 max. It's the state 1 property of an electromagnetic wave. I could give you 3. They reflect, they refract. I'm going to give you 3. And they travel at a speed of 3 times 10 to the 8 meters per second. Right, so you have 3 right there. That's 1 Mach. Just put 1. I just gave you 3 so that you would have options. Now moving on. This question 3. Elements of answer. All of this is a lot of literature, so I already have it written down. So I'm just going to read it back to you. Let's read it back to you. So it says, elements with unstable nuclei are susceptible to decay. What is meant by the term nuclear fission? So fission means the splitting up of an atom that gives off a lot of energy, and there's always mass loss somewhere. And don't forget to read over fusion, nuclear fusion. So if you have some time this morning, nuclear fusion is a very short read. It's taking no more than 20 minutes. So read over that because I feel like they're going to bring nuclear fusion somehow because they've been bringing the fission part. So nuclear fusion is cleaner than nuclear fission. And what it is that it's the fusing of 2 atoms, right? And it's usually the isotopes of hydrogen, which makes it a very clean process. Okay? So what it does, it makes a bigger atom, a bigger hydrogen isotope, and basically you have a lot of energy. It's the same idea, just that you don't have to suffer the repercussions of radioactive waste that is detrimental to your health and survival. Now it says state 2 advantages of utilizing nuclear energy. Small amounts of nuclear fuel may be used to produce an enormous amount of energy or electricity. Hence, delivery and storage of the fuel is relatively cheap and it can be used in medicine. Then we have here workers in nuclear power plants need to be extra careful on the job. State 1 precaution that workers in nuclear power plants need to take. 1 is that they could use robotic thongs, arms, or gloves while employed. They also need to wear special protective clothing. This needs to be done on the ground. And they also need to have special signs, hazmat signs, placed all over the place in their work areas. Then it says, give 2 disadvantages of using nuclear reactors to generate energy. First off, if there's a problem, if there's a nuclear leak, that leak can affect us and alter our DNA in our cells, which can produce cancers and other abnormal growths. So we become mutants of what we once were. And also, nuclear power stations are very costly and hazardous. They're costly to build, right? And they become hazardous when they are not built properly. Okay, in the essence of time, I'm just gonna let's go. So it says here, uranium isotope U-238 undergoes nuclear fusion. See, fusion when struck by a neutron. And so we have barium-139 and krypton-97 nuclei are emitted along with 3 neutrons as shown in the following equation. So we have this and this. These are our reactants. and these are our products. Okay, so we have 1 mole of barium, 1 mole of krypton, and 3 moles of neutron. So what we're going to do now, we're going to state the value of P. P must be equal to this if you add back all of these. So since this is 0, all I did was say 92 minus 36 to give us 56. So 56 plus 36 will give us 92. 92 plus 0 is 92. 56 plus 36 plus 0 is also 92. Now it says here, what is the meaning of C in Einstein's equation? It's the speed of light, which is 3 times 10 to the 8 meters per second. Then calculate the total mass of the elements formed after the reaction. So they want the products. So what you would do, you look for the products here. You have barium. You have 1 mole of barium, so you just add 1 mole. You have 1 mole of krypton, so you just add that. You have 3 moles of neutron, so you have to multiply this by 3. Then you add them up. When you add them up, make sure you use brackets so you can get the correct answer. So you would do this. Bracket 232.560 times 10 to the negative 27, close bracket, plus open bracket 152.620 times 10 to the negative 27, close bracket, plus 3 times 1.670 times 10 to the negative 27, and voila, there is your answer. It mirrors exactly what I have. Right, so make sure you use those brackets wisely, otherwise you're going to get incorrect answers. Now it says calculate the energy released in the reaction. So you have to work out the mass before. And once you work out the mass that you were dealing with before, you subtract the mass that you got after. Remember, there's always mass loss, so you take the mass before minus the mass after. So the mass before included 1 mole of the uranium atom and 1 mole of the neutron. And so I just looked for the masses of those and added them back with the same method. I use using brackets, 398.350 times 10 to the negative 27, close bracket, plus 1.6, open bracket, 1.67 times 10 to the negative 27, and you get 4.0002 times 10 to the negative 25, and it's there. And once you get that, brackets, can't be too careful because, sometimes your calculator is not that smart. So taking the value from the page before, oh boy, I forgot to put my bracket. Okay, so putting it in bracket 4.0002 times minus open bracket 3.9019 times 10 to the negative 25, and we get 9.83 times 10 to the negative 27. And so once we figure out delta M, we just stick it in. And we said that times 3 times 10 to the 8 times 3 times 10 to the 8. You get 8.847 times 10 to the negative 10 joules. And remember that you will get kilogram meters squared over second squared. That is equivalent to 1 joule. Okay? And here it says state one use of the energy released from the reaction. I'm going to give you 2. It's to provide cheap, affordable electricity to homes. And also it's used in nuclear warfare. So, we all know that. The atomic bomb that they used to blow up the island and Hiroshima and all that. So you would have gotten number 4. This was a lost file that got corrupted on my phone, so I had to do it over. Wishing you all the best in your exams today. make sure that you gather up as many points as possible. Make sure when you're dealing with your graph, you read through the first question fully, because you don't want to make a wide scale on your graph, and then when you look in another question, they're telling you to extrapolate to the y-axis, or extrapolate to the y-axis coming this way, and then when you look, you have no space to extrapolate because you made your graph too big. And then you have to rub out the graph and do it over again. That's a waste of time. So make sure you read through the entire of question 1. Don't rush question 1 too much. Read through the entire question 1. Make sure that you don't see any extrapolations, so you could determine if to make your graph really big and nice. Okay? What else can I tell you? If you don't know the answer for a question, pick up the point somewhere else, okay? They don't expect you to know all the answers. They don't expect you to know all the answers. If you do, kudos to you. But if you don't, move on. Gather up as many points as possible. If you had a good SBA grade, don't just rely on that, because that is a false hope. Just make sure you do your best in paper 2 and paper 1, so that you could at least, get the best grade you could get. Don't just sit in the room and, oh, well, at least I have my SBA grade. No. Don't use that as a cushion, right? Drive yourself to get as many points as possible. The test, I think, is out of about 100 points. Let's see. You have 25 for the first one, and all the rest are 15. So that's 2, 3, 4, 5, 6. So 6 times 15. You're looking like the test out of 115. 2, 3, 4, 5, 6. That's 5 questions. Let's see. 15. Question 2 is 15. Plus question 3. Question 3 looking like it's 15 as well. Plus question 4, 15. Question 5, 15. And question 6, I'm pretty sure it's 15. Yeah. The first question is 25 points. Let me see, 1, 2, 3, 4, 5. Oh, I multiplied by the wrong thing. So it's out of 100. So you have 100 points you could get out of this. 100 points. So if you get at least 50 points, guess what? You're in the clear. Try though to get beyond 50 if you can. The test is out of 100 points, people. Try your best. You're doing them. Do them smart and fast. Don't forget that if they ask you what the quantity is of the graph, whatever it's looking for, is always the unit of the gradient. So if you had meters per second here and seconds here, then the quantity would be acceleration. You had meters here and seconds here, then the quantity would be speed or velocity, because it would be meters over seconds. So all of that you just pay attention to. If you're not good in electricity, leave that for last. You should be really good in light and all those other ones. If you're not good in atomic physics of the atom, what I would suggest to you is just feel yourself through. Come back to the ones that seem to pose a problem, which is always those two, electricity and physics of the atom. Okay. All right, so that's my best of luck on your exams this morning. Wishing you all the best again. It's not the end of the world if it's hard. Remember, some of the best and best paid people in the world, they had to do it many times to get there. Okay? So, with that being said, peace.